Alrighty, isosceles and equilateral triangles. So we already talked about what they are. Isosceles, remember you have two eyes that are the same, so you have two sides that are the same with isosceles triangles. Equilateral, that's the easy one, you know all the sides are equal. We're going to talk about properties of isosceles and equilateral triangles, how we can use them to find some missing information, and then also how to use them in a couple of proofs. So, isosceles triangle theorem, pretty simple. If two sides of a triangle are congruent, then the angles across from, I guess it should say, across from those sides are also congruent. So if you had something like this, these two sides are congruent, the angles across from them, kind of going across, are going to be congruent as well. Also works in reverse. If two angles of a triangle are congruent, then the sides across from, I don't know why I didn't write from in there, those angles are also congruent. So it works both ways. If the two sides are congruent, angles across are congruent. If the two angles are congruent, those legs or those sides across are also congruent. So let's put this to the test. Okay, let's see what we get here. Pretty easy idea. The two sides are congruent. So the two angles across from it are congruent, so x has to be 55 degrees. Okay, not too difficult. Okay, again, sides are congruent here, so the angles across have to be congruent. So this is 64 degrees. Okay, so we can go ahead and find x now, not too bad. 180 minus 64 minus 64, so that's minus 128. So x would be 52 degrees. Okay. To find y, well, we need to know at least one other angle in here. Well, we can look down here. That's a linear pair. So this has to be 180 minus 64. It's going to give you 116. Now, look at this triangle. Again, the angles across from those two congruent sides have to be the same. So we need them basically both to be a y. Or the other way to think about this is say, okay, 116 plus 2y equals 180. The other way you can do it is say 180 minus 116 and cut it in half or divide by 2. That's the exact same thing as what I have here. So subtract 116, 2y equals 64 degrees, divide by 2. So each angle here is 32 degrees. We don't need to know this one, but it would be 32 as well. Easiest way to check if you did it right, make sure they all add up to 180. Triangles always add back up to 180. Okay. Alright, let's see what we got here. Throwing an equilateral triangle. Alright, if this angle is 60, these both have to be the same thing. The algebraic way to do this would be 2x plus 60 equals 180. A lot of you probably just did 180 minus 60 and divided by 2. Either way works. You're going to find out that x has to be 60 degrees everywhere. Okay, 60 plus 60 plus 60 equals 180. We know that both those angles have to be the same. If we look at a couple more examples here, okay, I want to find the missing angle in this particular side. So we would say that these two angles have to add up to be, with this third angle, 180. Okay, let you guys figure out what that missing angle is. So try this one. You guys can also handle that one. And again, in this last example, I'm just showing you, okay, if these three angles are all the same, all the sides across have to be the same. It's an equiangular and it's also equilateral. Okay, all those sides across from the equal angles are the same. So try to find that missing angle in that first one I highlighted. Try and find the missing angle and also maybe the missing sides, or what the sides have to be in the one with the 45 degrees. Okay, and see what we come up with for tomorrow. More algebraic example. In isosceles triangle RST, so we already know what isosceles means, that RST, oops, I didn't read the directions all the way. R is the vertex angle, not S, so R has to be up here. So we know this is S, this is T. The measure of angle S is x squared minus 12. That's the angle measure. The measure of t is 4x. So here's our two measures. Find the measure of each angle. Okay, so we have a little bit of work to do. Across from congruent sides are congruent angles. If they're congruent, set them equal. Should look familiar. Get that x over, so we're going to have x squared minus 4x minus 12 equals 0. I want you guys to go from there. Figure out what x is. If it's both answers, if it's just one, plug it back in, find t, find s, and then from there you can find out what angle r would be. So try that, finish that one for tomorrow. Looking at a couple more examples. Okay, again, for the most part, these are pretty easy. If you see the sides, you see the angles that are congruent. Going across from that side, that angle is congruent to that angle. So if this angle is 42, this angle is 42. You know two of the angles of a triangle, you can always figure out what the third angle is. Once you know that third angle, you can find this angle using linear pair. I want you guys to figure out what x is. So what's x for tomorrow? I want you guys to do A. Okay. I'd also like you guys to do B. Again, just using those missing angles. Again, you know that these are vertical angles. You can figure out what one of them is. Kind of go from there. And C. Let's see if I want you guys to do this one. Alright. We know that all these angles are the same. So this is a little bit of a tricky one. If we know all these, I'm sorry, I meant sides. If we know all these sides are the same, all the angles have to be the same. The only way all the angles can be the same and it be a triangle is if each one is 60 degrees. That's the number one thing that we have to find here. Okay? If that angle is 60 degrees, this angle has to be 120 degrees, linear pair. If we know that those angles are 120, looking at these, on this right triangle, not actually a right triangle, but looking at this triangle on the right side, across from those congruent sides are congruent angles. Okay. The only way for those two angles to be congruent and this whole triangle to add up to 180, we know 180 minus 120 is going to be 60 divided by 2. Each angle has to be 30 degrees. So we can say that 5x plus 20 equals 30. We need to find out what x is going to make that happen. Subtract 20. 5x equals 10. So x equals 2. Okay. So again, across from those congruent sides are congruent angles. Across from congruent angles are congruent sides. Let's take a look at one proof with isosceles triangles. Okay. BAT is isosceles, alright, so we know that part. M is midpoint of AT. Okay, there's our other given. We're going to prove that these two triangles are congruent. So again, always start with the given, take it till you have some information. So, triangle BAT is isosceles. It's given. Now, that doesn't give us anything, no A or no S, so we have to keep going. Let's figure out what else we know off of that. So if BAT is isosceles, we should be thinking this. So now we can go ahead and say that BA is congruent to BT because the legs of an isosceles triangle are congruent. So now we have an S. Okay, so we have some information there. Okay, keep going. There's actually more information you can get out of that. We know that the angles across from those sides have to be congruent. So we can say that angle A is congruent to angle T. Angles across from congruent sides are congruent. Okay, something like that. Again, doesn't have to be word for word. So now we just came up with an angle. So we have an angle, we have a side. Done with that. There's nothing else we can come up with from that isosceles triangle part. If we keep going though, we can use our next given. M is the midpoint of AT. So that's going to tell us something here in a second. Again, that's a given. It doesn't actually tell us something now. It doesn't give us an A or an S. But in our next step, we're going to be able to do this. So we're going to be able to say that, lost my train of thought, AM is congruent to TM, and this one, oops, that should have been a 4. This one is one that we've talked about a bunch. Midpoint creates 2 congruent segments. Just got an S. Alright. We can finish this up by saying that triangle BAM is congruent to triangle BTM by, okay, see how we did this? Let's go, okay, so we started at a side and then we went, so if I outline it here, we went side, angle, side, side, angle, side. So that's what we used, side, angle, side. And we did that with using 2, 3, and then 5. Now, if we look at this, some of you might be wondering why we couldn't have used MB or BM, that middle part of the triangle, as a side, because if we did that, what would happen is we would be looking at an angle side side, which we know does not work. You cannot use that, so we would not be able to use that in this particular case. I want you guys to try this one. So I want you to see that you guys actually tried it. You have some effort down. You can always go back and adjust it, but you have some work down on this paper. You're making sure you're trying it. You're making sure you're going to prove that these two triangles are, or I'm sorry, that BAD is isosceles. So kind of working backwards. Try it. See what you can come up with. We're going to go over that one in class tomorrow, and then we'll probably do this extended proof where we have a bunch going on. If we can handle this, we can handle them all. So again, a shorter video. Make sure you're taking your time on these. Rewind, go back, watch things if you need to. Come in for some extra help. Make sure you guys finish this unit on a good note. These proofs are not hard, or I'm sorry, these proofs are not easy. They're also not too hard if you understand them at the beginning and you've been working, you've been doing this stuff. So yeah, they can be hard if you've been struggling, you haven't been watching the videos. But if you've been watching videos, you've been taking the notes, doing everything in class, you should be just fine on these. They should be easy by the end of it once you understand them. So make sure, again, you come in for extra help. At this point, I'm pretty much rambling, so you can either pretty much turn off the video, stop listening to me, or I'll just keep talking. Let's just turn off the video.